Now let's talk about slopes and tangent lines in polar. Suppose I have some general curve, r sum f of theta, and I have a point r theta, and I want the tangent. And usually when I want tangent, I want dy dx. So let's see if we can come up with this formula. I know y is f. If you guys mind, I'm going to use r sine of theta. And x is r cosine of theta. Now remember when we did parametrics with respect to a variable, the derivative of y with respect to x is going to be the derivative of y with respect to theta divided by the derivative of x with respect to theta. Now the problem here is r is a function of theta. So let's find dy d theta. I have to use a product rule. So this is r prime sine of theta plus r cosine theta. And dx d theta is r prime cosine of theta minus r sine of theta. Okay, the r's aren't constant, so those don't go away. So this product rule shows us that this ratio isn't going to be something nice and simple. It's going to be, you know, our function times cosine plus the derivative of the function with respect to theta times sine divided by minus f sine theta plus f prime cosine theta. Now, folks, I don't memorize this. I get too confused, so I figure it out every time I need to use it. Now let's look at where we're going to have horizontal and vertical tangents. A vertical tangent is going to occur when the denominator is 0. So when this is 0, you're going to have a vertical tangent. And when the numerator is 0, you're going to have a horizontal tangent. If both numerator and denominator are 0 at a point, then you cannot make any conclusions about the tangent. You need to look at some other aspects of your curve. Let's look at this curve right here. R is sine theta. R prime, in this case, is cosine of theta. So what is my derivative with respect to derivative of y with respect to x? What does that look like? Well, it's r cosine theta, so it's sine theta, cosine theta, plus r prime sine, all right, divided by, I can't go backwards, minus r of theta, so that's sine, times sine, plus f prime, so this is cosine. All right. So what does this become? This is 2 sine theta cosine theta divided by cosine squared theta minus sine squared theta. So let's look to see where we have vertical tangents. We're going to have a vertical tangent wherever cosine squared theta is equal to sine squared theta. All right, and these are going to occur. Let's see, what is this? So this is where's tan squared theta equal to 1? Well, that's when theta is pi over 4 and 3 pi over 4. So there are our vertical tangents. Where are we going to have a horizontal tangent? Well, where is 2 sine theta cos theta equal to 0? But that's just sine of 2x. Oops. Now, where is sine of 2x equal to 0? Well, when x is 0 and when x is pi, when 2x is pi, so at pi over 2. So I have horizontal tangents at 0 and pi over 2.